Hey everyone, welcome to Knowing Nuclear. In this episode, we are going to be talking about how our energy needs are increasing and why our CO2 emissions need to be decreasing. We need energy. A fairly simple, straightforward example that's particularly dramatic is if we look at the amount of artificial light that people use. If you go back to about 1700, the United Kingdom used 10 billion lumen hours per year. What does that mean? Well, let's use a 60-watt light bulb for scale. In the 1700s, the UK, which had around 8.5 million people, emitted the same amount of artificial light as roughly the equivalent of only 1,500 60-watt light bulbs running continuously for 1 year. And over time, that total lighting, which was largely candles, introduced town gas and then kerosene after that. Then, sometime in the 1950s, electricity really took off. This picture is a log scale, so it's a little confusing. The UK is now using 100,000 times the artificial light they were using around 1700. So this means they now have the equivalent of 1.5 billion 60-watt light bulbs running continuously every second of every day. 1.5 billion light bulbs is 100,000 times the artificial light. If our population were to have grown as fast as the lighting did, at the moment, instead of having, say, almost 8 billion people on the planet, we would have roughly 0.4 people for every square meter of land on the planet. That means everyone would have a piece of land that's roughly the size of a pool table. That's how much more lighting has grown than the population. And the expectation is that lighting will continue to grow as developing economies get better and better lighting and they get more access to electricity. Energy use isn't uniform across the world. Countries like Canada and the USA seem to have plateaued. The electricity use per person isn't really changing dramatically. However, there are other countries in the world who want their population to have access to the same opportunities that Canadians have been enjoying for decades, and their energy use is catching up to ours. So we need energy. The downside is, as we talked about in our energy choices video, most of the energy we get, 5-6 of it, is coming from fossil fuels, so natural gas, oil, and coal. So the experts sat down and looked at this, and they agree. Climate change is real. Climate change is us, specifically our fossil fuels, and climate change is bad. Climate change is also starting. It's here. The floods, the droughts, the famines, the heat waves, the rapidly melting snow, all of this is real and happening now. It's not sometime in the future, although it's going to get worse in the future. It has already started happening. But here's the important thing to know. There is hope. Can we stop climate change entirely? No. Can we avoid most of the really deadly, dangerous, destructive climate change? Absolutely. The more we act and the faster we act to change our energy sources from those fossil fuels to things like nuclear, the more good we can do in the world. So, switching primary energy sources is imperative. We have to do it to stop climate change and to keep our way of life. But we've got this dilemma. A dilemma is not just a problem. It's when you have these two opposing things that you need to balance. So if we stop using all of our energy, we would starve to death in the dark. It would be very, very bad for us. But if we keep doing what we're doing, that will also be very bad for us. Let's take a look at this graph. If we look at coal and natural gas, those release a fair amount of CO2. The red bar is the direct emissions from generating energy using that source. The blue bar is the total emissions, which includes emissions from energy generation and indirect emissions. Indirect emissions include activities like building the coal-fired power plant, mining the coal, driving the coal to the plant, and more. The indirect emissions aren't really that high. It is burning the coal that's the huge problem. Likewise with natural gas. Pulling the natural gas out of the ground, shipping it, and processing it, and so forth increases the total emissions of the energy source. That means it's more than just the CO2 emitted from the natural gas power plant. That blue line is almost certainly low because we're finding increasingly there's a lot of what's called fugitive emissions. So natural gas escaping up into the atmosphere and changing the climate. Biomass, solar, geothermal, hydro, nuclear, onshore wind, offshore wind, all of these are much lower. How much lower? Is geothermal really 3 less than the solar on your roof? Those numbers are really hard to tell because it depends on a lot of things. The important thing is not those absolute numbers, but the fact that you've got those huge emission numbers for things like coal and almost nothing for something like nuclear. That's the important thing to notice. Is it 11? Is it 12? That's hard to say, but the big differences are what we're looking for here. So it is hard to dramatically reduce our CO2 emissions, but it is possible. And we're going to need every tool in our tool belt because all of our energy uses, like lighting or heating or transportation, lead us to having the kind of life where we can continue to study after the sun goes down, or keep warm on a cold day, or keep cool on a hot day, or reach a doctor's office really, really quickly. The solution to our dilemma is that we have to work hard to replace fossil fuels as our primary energy sources with biofuels, nuclear, solar, wind, geothermal, wave, hydro, and tidal power, because ultimately we need more energy and less CO2.